How's everyone doing? Good? Everyone ready to party after this long day? So, yeah, I'm Robert Ward. I'm the co-founder and currently the principal architect at Juristat. Juristat was founded in 2012. We're a company dedicated to helping patent attorneys do their jobs better. We started out as an analytics company, providing tools and information to help attorneys make kind of better decisions. And then in 2019, we expanded to what we call workflow automation, which I'm not workflow orchestration, workflow automation. I'll get to that a little bit in a second. We currently work with a third of the world's biggest patent filing law firms and a bunch of companies. The two biggest ones I can mention are TSMC and Lenovo. Promise there's a bunch of other names you'd recognize. I just can't tell you because of NDAs. So what is workflow automation? Well, in our context, a workflow is a set of steps to prepare some materials to get handed off to an attorney. Doing some amount of work, whether it's collecting documents from the USPTO, collecting documents from wherever they happen to be, parsing templates, building out boilerplate, basically anything that isn't the actual kind of intelligent work that you're paying your attorney for. You don't want to pay your attorney to fill out forms and copy information from one to another. We do all of that so the attorneys can focus on the work they're being paid for. The problem we had about a year ago that we wanted to try to work on was we have a bunch of automated systems that do all sorts of things. Talked about document fetching, parsing, building reports, and then we would compile all of that information and we would hand it off to one of our internal experts who would do the rest of the work, the tweaking, the bits of work that require expertise that can't be automated, and then they would hand it off to our clients. The problem that we had was that those analysts need to be very highly trained because they need to be able to interpret legal language, they need to be able to do every single part of the process, but they're also doing a lot of stuff that you don't have to be highly trained for. We weren't able to use human input, human work in other automated systems, so we would have analysts who were doing things like parsing documents and then manually copying that data to other places. Just a waste of everyone's time. Difficulty changing processes. I don't know if anyone's ever managed people before, but when you decide, hey, we've been doing things this way, we're going to do things this way, it's often hard to get people who are set in their ways, especially if they're doing repetitive same thing over and over again, to change that process and work on something else. And everything's serial. So, we hand all of the work for one, we call it a packet usually internally. If that packet takes 6 hours, well, there's one person doing 6 hours worth of work, even if it's a lot of it's repetitive and could be split up more intelligently. The solution is we call it our assembly line model, and it's breaking up that human work that used to be done by a single person into a bunch of smaller reusable tasks that can be done by multiple people, done by different people with different training, done by consultants, done by temps we hire for busy seasons, basically allowing us to split the work up so we don't have to have everyone trained to do everything. And yeah. Solution goals, we wanted to define our whole process end-to-end in code. So instead of those having to give the instructions to say, here's how you fill out this template, here's how you do this, then copy these files, we wanted to be able to define everything, even the work the humans were doing in code. We wanted to make it easy to call a human task. So the way you might call an activity to go hit an API and get a response back, we wanted to be able to say, hey, have a person do some work for me, get the result back just like you were calling any other activity. And we wanted small reusable tasks. So our goal was that no task should take more than about 5 minutes. We don't want people to be doing a lot of work on one thing. We want to be able to mix it up so that we can not burn our people out, having them do the same thing over and over again, grinding on the same type of thing. And then we want to be able to parallelize where possible. Handle deduplication. This is huge for us. When we get new work we need to do, we'll call it a triggering event internally, and often the same triggering event will result in us building several different products for a single client that share some, but not all the work. And so deduplicating work to be done and not redoing it were big goals for us. You know, if we've parsed a document for a product we did 6 months ago, we don't ever want to have to reparse that document, but we want it to be kind of transparent if you're the engineer writing the code for it, whether or not that's going to a person, whether or not it's coming out of a cache, whether it's coming from an automated system, should be pretty much the same to you as the developer. High-level design, very minimal API layer, very minimal database. We'll call an activity from our workflows to insert a task into the database, send a signal with the results back. Mostly what I'm going to talk about today is the temporal workflow strategy here. The API layer, and especially the front end, are just going to be too specific to any use case for it to be worthwhile to show you what we've built. But we'll cover kind of the important parts that you actually need. Sample workflow. This is going to be the most contrived, stupid example workflow you've ever heard. Please forgive me. We take an input of a string. We extract all the digits from the input string, and then we ask a person to add those digits together. Let's ignore for the fact that computers are good at adding digits together and just pretend that that's an important thing we need a person to do, and then return the sum of those digits. So I'm going to talk about the temporal side first. Like I said, there's not going to be nearly as much detail about the API and front-end sections. Most of the kind of meat of this is going to be talking about temporal. After a lot of back and forth with the temporal engineers, a lot of trial and error on our part, what we ended up with is this 3-level model where we have 3 different workflows involved in doing human tasks. Highest level, your parent workflow, is going to be where your actual high-level work is happening. For us, it's preparing a packet for a client. For you, it'd probably be something else. There's a human task workflow, which conceptually you can think of like as a request, saying this workflow represents a parent workflow saying I need some work done. And then the do human task workflow, which represents actually interacting with a person to make that happen. The reason we have those two workflows there is for deduplication. It makes it easy to track, okay, what has my parent workflow requested, and then what work is actually being done. And we'll talk more about kind of the relationship between those in a bit. So the goal of our system is to have a function you can call similar to an activity, although in our case it's just a wrapper function for an execute child that schedules a human work, validates the result, and then gets you the output. Hope that's somewhat readable. So for our kind of contrived workflow, we've got a parent workflow here that's saying, got an activity to get some digits from a string. We're going to request the human to add the digits together and then return doubling of the result. Kind of demonstrating that we can send some input to a human, get the result back, and then do more work on top of that result once we get it back. Our task wrapper, kind of a standard execute child workflow. The reason we usually wrap our human tasks inside of a function is we're all in TypeScript, so it allows us to provide some type safety. Often we'll need to parse results and validate that the response looks like what we're expecting, but also allows for standard options to be set on workflows. If we know that we always want to take 7 days to parse a document or that kind of stuff, we can set those options in a helper function and make sure they're standard. So the human task workflow is always going to be called with a unique ID. You can see there we're putting a UUID at the end so that we're always going to have a unique ID. And this human task workflow represents, like I said, the request. It represents your parent workflow saying, I need some data. This human task workflow is in charge of the actual signal handling, communicating with the external systems, and then it will also do the deduplication for when you're processing the same input. So you can see here, we're setting a signal handler, waiting for the result, and then kind of the meat and important part of this is the signal with start for the human task. So in the signal with start, most important part is getting a deterministic workflow ID for the input. Whether or not that's canonical JSON or some way that you have to create a workflow ID that, given the same input, is always going to produce the same workflow ID. That's kind of the most important part here. We're handling the memoization of the result inside this activity. There are different places you could put it, but this makes the most sense for us. If we have a result for that workflow ID already, we can just call the signal, go back to the workflow, and get the result, not do anything else. If we do need to have a human actually do some work, though, we do signal with start. And it's going to be kind of a pub sub model. So we say to the do human task workflow, we're going to subscribe with a signal that says, hey, notify me when a person's done this. So if 10 different workflows all want the same piece of data from a human task, they're all going to subscribe to the result, but you're only ever going to do that task once. And that was really critical for us because we were constantly having analysts duplicate work across multiple product lines. The actual do human task workflow handles the human task interaction, pre and post processing. We're doing the memoization at a different level, so I didn't update this after I updated my example code. But will only ever be called once for a given task. So we've got a couple signal handlers here. First one, subscribe, the subscribe to human task signal. So we're saying, hey, get the list of workflow IDs that we want to notify when the task is done. Then the other signal handler is coming from our external task system saying, hey, here's the result of your work. And then since we're doing the signal with start, that subscribe to human task completed signal handler is always going to be called first when we start up a new workflow, but will be called by additional, possibly called by additional workflows. So now we've got some input. We know we need to actually do it. We're going to submit our task to an external system, whether that's a direct database call, API call, kind of depends on your implementation. But you're essentially putting an entry in an external system that says we need a person to do some work. And then you're waiting for that signal handler to get called from your external system to say, hey, here's your work, it's done, ready to go. Once you're done with that, you're either going to signal success, signal failure, depending on, maybe you got it back and you didn't validate it. It didn't validate properly. Maybe it's successful and you get it. Either way, communicate that back up to your workflow. So now we're back. We've been signaled from the do human task workflow back to the human task workflow. We have our result, and then we can say, hey, return the output or throw an error depending on what happened. And now we're back up to our parent workflow. So we've requested a person to do some work, we've got the result, and now we can use that in further kind of computation as we go. Any questions about the workflow stuff before I go on to the API? Oh, go.
What was the reason for using 3 different workflows, the parent workflow, human workflow, wait for human action workflow, and then the actual human action workflow?
So you could just do like the signal to subscribe to the result and get the output from your parent workflow and skip that one in there, do the signal with start. For us, we really liked the observability of being able to see from a parent workflow, it's waiting on 15 documents to get parsed, and we can pull that up in the temporal console, see those relationships. Once you do the signal with start, you don't have a parent relationship anymore. So you would have to build your own kind of way to introspect to see like, what is this workflow waiting on? What's it actually doing? Whereas if you use the model we have, you kind of get that for free with Temporal. We don't have a high volume enough that spending the extra workflows, in our cloud bill isn't going to be noticeable to us. If reducing your cloud spend is important, that might be a different decision you'd make. But for us, the observability was worth it.
And then do you create a different unique workflow for every unique human action, or do you wait for all human actions in one workflow?
We have a unique do human task workflow for each input, set of inputs. So a given set of input to the task produces a deterministic workflow ID. And so given the same input, it's going to have the same do human task workflow, which is how we memoize the result and how we deduplicate when we're calling them.
I have some overlap with that.
Okay.
I'm wondering about the subscribers to default back, as opposed to getting a workflow handle and just awaiting the completion.
Yeah, we didn't want to block in an activity, having it running, and so doing the signal handlers means that when we're waiting, which in our cases could be days or weeks waiting for tasks to complete, means we don't have to have anything running.
So you're doing the signal with start from an activity?
Yeah, signal will start from an activity, but then that activity returns immediately. And then the workflow is just waiting for a signal.
Question, do you have any requirement for you to display the current workflow status anywhere outside of the Temporal system?
We do. We actually just implemented that, integrated as we slowly kind of let Temporal eat more and more of our workflows, we're using queries now to display kind of on our internal dashboards the status of where things are at. So we can just say like, here's this stage in the process, here's this stage, and we're using queries now to get that data back out.
So basically, still you don't maintain your own status data because it's outside of the Temporal system.
Yeah, we try to have, our goal is eventually to have Temporal be our one source of truth for the status of all this stuff, so we don't have any sort of state maintained outside of our Temporal workflows about where things are at. Cool, I'm gonna talk quickly about our API here. Only 3 real things you ever need to do. You need to be able to start a task, heartbeat a task, and complete a task. One kind of requirement I didn't talk about before was that we need to be able to kind of, with the theme of durable execution, we need durable human execution. So if a person starts a task and then goes to the bathroom and gets distracted and doesn't come back to the task, we need that task to get picked up by another person and continue to execute. So heartbeat was important for us in that respect. In a transaction, you want to list available tasks and self-assign the next one. How you want to handle assigning tasks, again, that's something that's going to be so specific to your use case. In the demo, in the sample code, it just gets you whatever happens to return on the next one. There's no real rhyme or reason to it. And then you send the task input to the person so they can start working on it. Heartbeat a task, at a set interval, you just say, hey, I'm still working on this. You can also do checkpointing here. That's something we've just recently implemented where if someone gets halfway through parsing a document, validating document parsing, we include that checkpoint with our heartbeats. And then if someone picks that task back up, they get to start where the other person left off, so they're not starting from scratch. That kind of checkpointing can be really handy depending on your use case. And then you mark the task as complete and signal the workflow with the output. One thing that I'm really excited about, did anyone else hear the announcements about Nexus today and just start to immediately rethink everything about how you're doing your Temporal workflows? That happened to me while I was realizing that a lot of this talk would change if I had access to Nexus. One thing we're excited about is being able to switch a lot of this stuff to updates, you know, especially with the completing of the task, being able to send the output back to the temporal task, get it validated, and then return some feedback to our API about, you know, whether or not it was accepted. Right now, it's just very fire and forget, right? If the human task has produced invalid output, it gets fired there, and there's no real way for us then to loop back in the person and say, hey, this doesn't look quite right, take a shot again. So we're excited about switching over to updates for that. And then the front end, I'm not even going to get into it. There's no front end in the sample. It's just you call curl commands to send the data you want to send. But you do need to heartbeat. It can be simple or complicated. Probably going to need a different front end for each task type. So what are the results of this have been for us? Generating citation sheets is the project that we've deployed this on initially. I'm guessing most of you are not familiar with prosecuting a patent, but one thing that you frequently have to do is say I have 50 patents that are related to each other. If an examiner on this patent over here says, hey, here's some prior art that I don't like that I think applies to your patent, then you have to then, in every other patent that could conceivably be related to it, you have to file a document that says, hey, here's some prior art that might be relevant. And so that's the first product that we've kind of brought this to bear on. The results have been that on large packets that used to take one analyst would be working on a packet for 2 to 3 days, parsing hundreds or thousands of documents, and then producing some output to the client. We can now, using temp workers, we parse those documents and can have the results for even our largest IDS packets done in hours instead of days, which has just been amazing for us. A lot of reduced errors. So we actually do a double stage when we're doing document parsing. So we'll send a document to be parsed by a person and then send it to another person for review. We do automated parsing, we have a human review and then another human review, and the reason is just that the consequences for messing this up can just be so high for our clients. In a major patent fight, if they discover that some cited art that needed to be disclosed wasn't disclosed, that can be a reason to get your patent thrown out. And you can imagine in big patent fights like the kind we see, playing out in the news all the time, that's a big deal. And then the ability to alter workflows in code has been amazing for us. So we can have a manager who now gets to do a triage and say, hey, this needs to be done here, this needs to be done here. They select some options, and that triage is itself a human task, and then it controls what actually happens with the workflow. So now there's no longer, instead of that happening in a Slack channel where one of our analysts says to their manager, hey, what should I do here, should I do this? All of that just happens, defined in code. Tasks get routed to the person they need to be routed to. Future projects, we want to switch to updates for all task interactions. We don't want our API to be attached to the database at all. We want to have Temporal be the entire communications layer, and the API just gets thinner and thinner and thinner. And then this is one that I've actually been talking with some of the engineers from Temporal about, trying to figure out a way to hook into the data encoder to use it for task inputs and outputs. Task outputs, when we're going through the signal, get run through the encoder, but we've been trying to figure out a way to hook into that encoder to use it for task inputs as well. Future projects for us specifically, we want to capture more workflows. IDS is our main, is the one we've done first. We have another big product called OAR, Office Action Response, that we're hoping to capture. We also want to figure out a way to do anonymous assignees. So we've been looking at how we can assign a task to a person with an email address and then let someone external to the company send them an email and say, hey, we need you to sign off on this document. Hey, we need you to take a look at this and make a decision. And being able to do that with external assignees would be really valuable for us. And task reviews, which we've implemented since I finished this talk. So that's it. If anyone else is doing human-in-the-loop tasks, I'd be really interested in hearing about your experience. We did a lot of rounds of kind of back and forth and a bunch of different attempts at this, but this has been working pretty well for us for the past several months or so. And it's only kind of made us want to double down on Temporal and get more of our stuff into it. Thank you, everybody.